Hi friends, welcome to Naresh IT. Today let us discuss a concept called problems on numbers, LCM and HCF. Now this chapter is very important as far as written test is concerned. You find many companies giving questions from this chapter, especially TCS. Now let us discuss the different types of questions that can be asked in this chapter one by one. Now let us start with the first question. The first question, how many zeros are there at the end of 100 factorial? That is, if you multiply all the numbers from 1 to 100, in the answer, in the end, how many zeros are there? Now one way of answering this question is we need to multiply all the numbers from 1 to 100, see the answer and check how many zeros are there. But it's very huge task, it's a very time consuming process, it may take lots and lots of time. Then how to tell the answer for this question in a very simple way? For this, first of all, we need to know some basic points which are required to answer this question. The first thing that we must know to answer the questions is prime factorization. Now what is prime factorization? Expressing a number as a product of prime numbers is prime factorization. Now let's take a small example and see what is that. Suppose I want to prime factorize 20, 2 10s, 2 5s. So 20 can be written as 2 into 2 into 5. Now this is prime factorization, expressing a number as a product of prime numbers. So here I am expressing 20 as 2 into 2 into 5. So this is prime factorization. Now let's take one more example. Now how to prime factorize 80? 2 40s, 2 20s, 2 10s, 2 5s. So 80 can be expressed as 2 into 2 into 2 into 2 into 5. Now this is a concept we are going to use to solve the questions in this chapter. Now along with this, let's take a small example. Product of which two prime numbers will give us a 0 in our answer in the end? Definitely it is 2 into 5. 2 into 5 is 10. If we multiply any other prime numbers other than 2 and 5, we don't get a 0 in our answer in the end. So product of a 2 and a 5 will result a 0 in the answer in the end. Now to this product, you multiply any prime number, definitely the number of zeros do not change in the end. If I multiply with 2, it is 20, you can see there is only 1 0. You multiply with 3, it is 30, 1 0. You multiply with 5, 50, 1 0, with 7, 70, with 11, 110 and so on. So for this answer, that is 10, you multiply any prime number, the number of zeros do not change in the end. Suppose if I want to increase the number of zeros in the end, what should I do? Now 2 into 5 is 10. Now I want to increase the number of zeros in the end by using only prime numbers. Then what is that I am going to do? Definitely I am going to multiply with another 2 and another 5. So the answer is 100. Now you can see the number of zeros have increased. Here I have 1 0, but if I multiply with another 2 and another 5, I have 2 zeros. So the logic here is, if you want a 0 in your answer in the end, multiply a 2 and a 5. You multiply 1 2 and 1 5, in the answer you get a 0. 100 factorial is product of all natural numbers from 1 to 100. So my question is, if you multiply all these numbers from 1 to 100, in the answer in the end, how many zeros are there? Now to tell the answer for this, logically speaking, I have to prime factorize all the numbers from 1 to 100 and find out how many 2's will be there and how many 5's will be there, from which I can tell my answer. Now first of all, let us try to find out how many 5s we get if we prime factorize all the numbers from 1 to 100. Now definitely, from where do you get 5s? You get a 5 from 5, you get a 5 from 10. If I prime factorize 10, it is 2 into 5. You get a 5 from 15, which is 3 into 5. You get a 5 from 20, which is 2 into 5, and so on. Now if you clearly see here, you get a 5 in every multiple of 5. 5, 10, 15, 20, and so on. So till 100, we have 20 multiples of 5. So definitely we find 20 5s there. Now along with this 20, we find few more 5s. If you look into the next number after 20, it is 25. If I prime factorize 25, it is 5 into 5. Now 1 5 is already counted in 20, because in every multiple of 5 we have counted 1 5. But you can clearly see there is one extra 5. So I need to add 1. Now the next extra 5 we find in 50. If I prime factorize 50, it is 2 into 5 into 5, and so on. The next extra 5 we find in 75. 3 into 5 into 5. The last extra 5 we find in 100, which is 2 into 5 into 5. So if you clearly see, the total number of 5s we have when we prime factorize all the numbers from 1 to 100 is 24. Now talking about the power of 2. Now where do you get these 2's? We get a 2 in every even number. Now from 1 to 100, we have totally 50 even numbers. So the minimum power of 2 should be 50. Actually it is greater than 50 only, because in 4 we find 2 2's, in 8 we find 3 2's, in 16 we find 4 2's, and so on. So the power of 2 is greater than 50. Now coming to the answer for this question, we know that if we multiply a 2 and a 5, in the answer there is a 0. Now here I have 24 5's and the number of 2's are greater than 50. But we can multiply 2 and 5 how many times? We can multiply 2 and 5 only 24 times. So definitely the number of zeros in the end should be 24. Now this is the general way of answering this question. Now how to tell the answer for this question in minimum time, that is maximum 10 seconds. How can you tell the answer for this question? Now let us look into the solution in another way, alternate way, where we can tell the answer in 10 seconds. Now the method we use to tell the answer for this question in 10 seconds. Write 100, divide with 5. Now you can see the answer is 20. Now the answer 20, you again divide with 5. You get 4. Now 4 is a number less than 5 and we cannot divide it. Stop. Add the two answers, what we got? 24. So the answer for this question is 24. Now this is the best way, simplest way to answer this question. Now let us take one more example to solve this type of problem, because while using this shortcut we may have some doubts. Now let us go for the next question. How many zeros are there at the end of 140 factorial? Now if you look into the solution, that is a shortcut. I solve the problem like this: 140 divided by 5, 28. Now many students, they stop here because they think that now 28 is not divisible by 5. No, we need to continue till we get a quotient which is less than 5. Now 28 when I divide with 5 actually is 5.6, but I cannot have number of zeros in decimals. So we need to write only the integral part, not the decimal part. 28 by 5 is 5. Now 5 again divide with 5, it is 1. Now 1 is a number which is less than 5, which I cannot divide it. So stop, add the 3 answers what we got. So 28 plus 5 plus 1, answer is 34. So the number of zeros at the end of 140 factorial will be 34. Now what is the logic behind we dividing with 5? Now many students may be having a doubt, why are you dividing with 5, why are you not dividing with 2, why are you not dividing with 7 and so on. Now actually the basic idea here is to find out the power of 5. Now we know that to find the number of zeros at the end, we need to multiply 2's and 5's. Now whichever power is less, obviously that would be the answer. Now obviously we know that the power of 5 will always be less than power of 2. A simple reason, we find a 5 after every 5 numbers, but we find a 2 after every 2 numbers. So if I can tell what is the power of 5, if I prime factorize all the numbers from 1 to 140, definitely I am going to get my answer. Now logically speaking, now what is this 28? Now these 28 are the multiples of 5 till 140, where you find minimum 1 5. What is this 5? Now this 5 is the multiples of 25, where we get an extra 5 like 25, 50, 75, 100 and 125. Now what is this 1? Now this 1 is a multiple of 125. If you prime factorize 125, it is 5 into 5 into 5. Now the first 5 is counted in 28, the second 5 is counted in 5, the third 5 is counted in 1 here. Now this is the logic behind we dividing with 5. Now let us go to the next question in this chapter. Find the remainder when 1 factorial plus 2 factorial plus 3 factorial and so on till 50 factorial is divided by 7. Now many students, they feel that it's a very difficult problem. To be frank, logically speaking, it's a very simple problem if we are good at basics. Now what are the basics we need to use to solve this problem? Now the first basic point that we must know to solve the questions in this chapter is, when you divide any number with 7, now what are the remainders possible? Now when you divide any number with 7, the remainders possible are from 0 to 6. That is, we cannot get a remainder 7 or greater than 7. Always it should be less than 7. Now this is the first point. Now the second point that we must know to solve this question is, all the multiples of 7, when we divide with 7, remainder will be 0. Now when do you say a number is a multiple of 7? When you can write a number in the form of 7n. Suppose I take a small example, 3 into 8 into 7 into 5, is it a multiple of 7? Obviously it is a multiple of 7, because this product I can write it as 7 into 3 into 8 into 5. That is, I am able to write it in the form of 7n, where n is 3 into 8 into 5. So the first point is, our answer should lie from 0 to 6. The second point is, all the multiples of 7, when you divide with 7, remainder will be 0. Now to tell the answer for this question, many students think that I need to find out all the complete value and then divide with 7 and find out the remainder. Actually we need not do it. For that, let us take a small example. 45, when I divide with 7, what is the remainder? 45, if I divide with 7, the remainder is 3. 7 6 are 42, I get a remainder 3. Now the same 45, if I split, I can split it as 22 plus 23. It's a small example, I am taking an example, divided with 7. This we can write it as 22 by 7 plus 23 by 7. 22, if I divide with 7, the remainder will be 1. 23 if I divide with 7, remainder is 2. So, ultimately the remainder is 3. That is, if I divide the complete value 45 with 7, remainder is 3, or if I split 45 into two parts as 22 and 23, divide it separately, add the remainders, I get the same remainder. Now, one more example, same 45, let us try to split it as 20 and 25 by 7. Now, 20 by 7 plus 25 by 7. Now, 20 if I divide with 7, the remainder is 6. 25 if I divide with 7, the remainder is 4. 6 plus 4 is 10. But we know that we cannot get a remainder 7 or greater than 7 when you divide a number with 7. So, what we have to do is again divide this 10 with 7. So, we get a remainder 3. So, either we find the complete value and then divide with 7 and get the remainder, or divide each and every term with 7, add the remainders, we get the same answer. Now, let us follow the second rule, that is, let us try to divide each and every term with 7, add the remainders and get the answer. One more small basic point that we must know before we answer this question. Suppose I say I divide a number with 7 and I get a remainder 2. What will be the remainder when I divide 5n with 7? Now, let me repeat once again. Let us suppose I divide n with 7 and I get a remainder 2. What will be the remainder if I divide 5n with 7? Now, there are many ways of thinking to tell the answer for this. Now, one of the general way of thinking to tell the answer for this is n if I divide with 7, if the remainder is 2, then this n can be written as 7x plus 2. Now, 5n. Now, 5n will be in the form of I multiply 5, it becomes 35x plus 10. Obviously, 35x is divisible by 7. Now, 10 if I divide with 7, what is the remainder? Remainder is 3. So, n when I divide with 7, remainder is 2. 5n when I divide with 7, remainder will be 3. One more, let us take one more example. Suppose I say 8n if I divide with 7, what is the remainder? Definitely n is 7x plus 2, 8n should be 8 into 7, 56x plus 8 2s are 16. So, 56x is divisible by 7, so remainder is 0. 16 if I divide with 7, remainder will be 2. Now, this is a simple logic I am going to use to tell the answer for this question in a very simple way. Now, see the logic here, the point is very simple. N if I divide with 7, remainder is 2. 5n when I divide with 7, what is the remainder? See carefully, 5 into 2, 10. 10 if I divide with 7, the remainder is 3. Now, the second point, 8n when I divide with 7, what is the remainder? N when I divide with 7, remainder is 2. 8n, so 8 into 2 is 16. 16 when I divide with 7, remainder will be 2. So, this is the simple logic I am going to use to tell the answer for this question. Now, let us solve this question. Now, let us try to divide each and every term with 7, add the remainders and get the answer. 1 factorial is 1, and when I divide with 7, the remainder is 1. Now, here I am writing down the remainders. 1 factorial is 1, and when I divide with 7, remainder is 1. 2 factorial is 2, when I divide with 7, the remainder is 2. 3 factorial is 6, and when I divide with 7, the remainder is 6. 4 factorial is 24. Now, definitely 4 factorial is nothing but 3 factorial into 4. Now, 4 factorial when I divide with 7, that is 24 when I divide with 7, the remainder is 3. Now, from now onwards, finding out the factorials and dividing with 7 is very difficult. So, very simple. Now, 5 factorial is 5 into 4 factorial. 4 factorial when I divide with 7, the remainder is 3. 5 factorial when I divide with 7, the remainder will be 5 into 3, 15. divided by 7, which is 1. Now 6 factorial is 6 into 5 factorial. 5 factorial when I divide with 7, the remainder is 1. 6 factorial when I divide with 7, the remainder should be 6 into 1, 6. Now talking about 7 factorial. Now 7 factorial is a number which is a multiple of 7, and all multiples of 7 when we divide with 7, remainder should be 0. 8 factorial. Definitely 8 factorial is also a multiple of 7, because in 8 factorial you find 7, 8 into 7 into 6 and so on till 1. So from 7 factorial onwards, every factorial till 50 factorial or greater than it are multiples of 7, and when you divide with 7, obviously the remainder should be. Now add all these remainders, we get 19. But we know that when you divide a number with 7, the maximum remainder possible is only 6. So divide this 19 with 7 again, you get a remainder 5. So the answer for this question is 5. Now let us try to solve one more question of the same model. Now let us discuss one more question of the same model which was asked in TCS. Find the remainder when 1 factorial plus 2 factorial plus 3 factorial and so on till 30 factorial is divided by 5 factorial. Same logic we apply, but how much is 5 factorial? 120. Now solution for this: 1 factorial is 1. When we divide with 120, the remainder is 1. 2 factorial is 2, and when we divide with 120, remainder is 2. 3 factorial is 6, and when we divide with 120, remainder is 6. 4 factorial is 24, and when we divide with 120, remainder is 24. 5 factorial when we divide with 120, obviously 5 factorial is also 120, and when we divide with 120, the remainder should be 0. 6 factorial definitely is a multiple of 5 factorial, because 6 factorial can be written as 6 into 5 factorial. So from here onwards, every factorial according to our question till 30 factorial is a multiple of 5 factorial. So obviously from 5 factorial onwards, your remainders will be 0. So the answer for this question is 1 plus 2 plus 6 plus 24, which is 33. Now one more similar type of problem. You try to solve it in 10 to 15 seconds. Let's discuss that problem now. Find the remainder when 1 factorial plus 2 factorial plus 3 factorial and so on till 40 factorial is divided by 11. Check whether you can solve this problem in 10 to 15 seconds or not. Now if I look into the solution, I directly write like this. I directly write down the remainders. 1 factorial, if I divide with 11, remainder is 1. 2 factorial, if I divide with 11, remainder is 2. 3 factorial, 6. 4 factorial is 24, dividing with 11 gives you remainder 2. 5 factorial, 5 into 2, 10. 6 factorial, 6 into 10, 60, but 60 if I divide with 11, remainder is 5. 7 factorial, 7 into 5, 35. If I divide with 11, remainder is 2. 8 factorial, 8 into 2, 16. 16 if I divide with 11, remainder is 5. 9 factorial, 9 into 5, 45. If I divide with 11, remainder is 1. 10 factorial, if I divide with 11, remainder will be 10. From 11 factorial onwards, you will get zeros. Now add all this. 1 plus 2, 3, 3 plus 6, 9, 9 plus 2, 11, 21, 26, 28, 33, 34, 44. Now we know that we cannot get a remainder 44 when we divide with 11. So again divide 44 with 11, you get a remainder 0. So the answer for this question is 0. Thank you for watching. For more videos, subscribe at www.youtube.com/NareshIT.